Chapter 9, Section 4, Real Numbers. Our objective is to compare and order real numbers. First, we need to talk about what rational, irrational, and real numbers are. Irrational number is a number that cannot be written as the quotient of two integers, kind of like the square root of 39 here. That also goes with can't be found easily in your head, so you can't find the square root of 39 easily. Therefore, you can't make it into a quotient or a fraction easily. Decimal form neither repeats nor terminates. So here we have 1.01001001001, and then the dots that mean it keeps going on forever. So we do have a pattern, but it's not a repeating pattern. So that means it's an irrational number. Anything else would be considered a rational number. So here we have a family tree of considering real numbers. Real numbers consist of all rational and irrational numbers. So here we have rational numbers. Inside of that is integers, and inside of that is whole numbers. And then everything else is irrational numbers. Square roots that we can't find easily, so square root of 12, or the pattern that we have here. Example 1, we are classifying real numbers, so we start with 5/8. If we take that to a decimal, we get 0.625. The decimal type, it is terminating, so it doesn't go on forever. So this is a rational number because it stops. Here we have 5/6. If we change that to a decimal, we get 0.833333, or we can write as 0.83 with a repeating bar over the 3, so it's repeating. Since it's repeating and has a pattern, it's rational. Square root of 19. We can change this to a decimal, and we get 4.358889, keeps going. So it's non-terminating and non-repeating. So it is irrational. You don't always have to put it in decimal form. This is just one way the book does it. 5/8 is a fraction, so it's rational. 5/6 is a fraction, so it is rational. Square root of 19 you cannot find easily, so it is irrational. Example 2, we want to use greater than, less than, or equal to. So which one is bigger, square root of 2 or 9/5? A good way to look at this would be to find the decimal of each one. Square root of 2 is 1.41. 9/5 is 1.8. So we have bigger. Let's go look at this real quick and classify them as 3/8. It's a fraction, so it's rational. Square root of 100 is equal to 10, so it is rational, because 10 over 1 can be written as a fraction. Square root of 6 I can't find easily, so it's irrational. Square root of 16/25. Well, square root of 16 over square root of 25. We get 4/5, which is a fraction, so this is rational. Example 3, it wants us to put these in order. So 4 divided by 3, 1.3, repeating. We have the negative 2.8. Square root of 3 is 1.73, and square root of 5, negative square root of 5, will be negative 2.24. If we put these in order from least to greatest, we have negative square roots of 5, negative, we take that back. Negative 2.8 is further to the left, then negative square roots of 5. These both have a 1, but then the 3 is smaller than the 7, so it comes next. And I should write that in the original form of 4/3. And then we have square roots of 3 here. So our homework is on page 473, starting with number 12. 3/4, we need to tell whether it is rational or irrational. 3/4 is a fraction, so it is rational.